Welcome. Now we'll be starting a new series, which is C programming language. I indulge you to please pay attention and also try as much as possible to understand the concepts that we are discussing about. Alright, so quickly let's get on to it. Now we'll be discussing a few concepts. The first one is C as a programming language. We're going to be looking at C in relation to other programming language. Then we'll also be looking at how is C program compiled, like the compilation process of C. How do you, from your source code, how does it get to your binary executable file or your .exe file? Thereafter, we'll also look at the C file structure, more like a guide, because it is an introduction to C. So these are what you need to know before we start talking about the more in-depth concepts in C. Then we'll also be looking at simple input and output functions in C. Like now we've known how we can arrange our C file. Now we still need to know how we can actually get inputs from a user, how we can also display output, because we need to get data. We also need to display data to the user. Then we will now talk on variables in C language, which is going to be the final topic in our discourse. Alright. So now, what is C programming language, or what is C language? Now, C is actually a multi-purpose language. Not just that, C language is very fast. Why is C language very fast? This is why. C language is close to machine code, meaning that in relation to other programming language, C is being referred to as a low-level language. So that's why you see some persons, they say C is actually a low-level language. Yeah, they're actually correct, because if you look at C in comparison to other programming language, you tend to see that C is much more closer to your hardware resource. By hardware resource, I mean your operating system, your kernel, and other stuffs like that. Now, in relation to other other programming languages, like assembly and stuff, C is actually still regarded as a high level language. So it therefore depends on the perspective of which you are looking at C. If you are comparing C to other programming languages like Java, Python, Go stuff, C is regarded as low level language, and C comes into use when you really want portability, because most operating systems are being built on the C language because it is very fast. If you are working with your hardware resource, embedded system, stuff like that, C is your go-to language. Even programming languages, they all have an implementation of C. Like in Python you have Cython, in Java too you still have C, and other stuff like that. Now, it's a structured programming language that is machine independent. By machine independent, I mean it doesn't necessarily have to be okay. It doesn't necessarily have to be the fact that when you are writing a C programming language on a Linux system, and then you take that exe file to a Windows system, and that particular person won't be able to use it. No, that's the reason of machine independent. C language is more like the right one to use many times. And you can see that the C programming language is basically used in developing operating systems such like the Windows, the Oracle database, Git, Python interpreter, and others. Now that is done, we also need to know how is the C code being compiled, or how is our C source file or our C file is being compiled. Now when you write in your codes in a file and then you compile it, there are basically 4 stages that your C file actually passes through. The very first stage here is the preprocessor. Now what is the preprocessor? Now the preprocessor job is basically just removing all global variables, removing all comments, and replacing them with their equivalent value to further hasten up compilation process. Now when you are writing your C file, there are some points that you make comments, there are some points that you are going to put in some macros, there are some points you are going to put in some variables and all that. Now when you are compiling it, the first place or the first bus stop in which your C file actually gets to is the preprocessor. Now when it gets to the preprocessor, it replaces the comment, the variables, your macros with their equivalent value. So if in your C source code you are written something like a like hash define max 200, and when it gets to and then in some parts of your code you've called the variable max. Now when this your source code gets to the preprocessor, it replaces every particular place that particular max variable was being called with its actual value. So if on line 20 you've used the name called max, now the preprocessor is going to remove or replace max with its value, which is now 200 in this case. And then when it is done replacing all global variables with their values and removing comments and all that, it now passes this file, or it now passes the results down to the compiler. Now when the compiler receives this particular code, it then compiles the C language, it then compiles your C instructions, or in this case your C codes. It then compiles it, and when it is done compiling it, actually if you kind of stop the process at the compilation stage, it creates a .s file. Probably the name of your file is testfile.c. Now when you pass in the appropriate flag to your compiler, probably you're using the C lang or you're using GCC, you pass in the appropriate flag to actually stop it in the compilation stage. It processes a .s file. That means your test file.c that was being passed to the compiler, which might be C lang or GCC. When you pass in the exact flag, what you get is testfile.s, telling you that it stopped at the compilation stage. Now the compilation now after this compilation stage, the next step is what? The assembler stage. Now the assembler in turn takes this code that have been, or this process data that have been done by the compiler, and then replaces every of those codes now with its equivalent machine code. In general we call it object code. Now you can also stop the compilation stage at this point. Most cases where you want to do that is when you're actually working with some like shared libraries and stuff like that, that you have to stop it at the object code phase, so that you can actually create your shared library, and then you can then group all of them into a particular library. Now once the assembler is done, the next step, which is the last one, is actually passing it to the linker. Now what's the job of the linker? Now in your C code or in your C file, you are probably using some predefined functions that came from some libraries, probably the input and output library, the standard library, or the unis td library, or the c types, the h library, whatever library you were using, whatever library function that you were using, or that you used in your C file. It's at this point in time that these functions, that because you didn't use them, and now the function definition needs to be linked to your C file. So it's the job of the linker to now link all functions that have been used by you in your C file with their appropriate libraries. So it links them up, and when it's done linking them up, it then zips them into an exe file. Now for a Linux system, by default it's called a.out, while for Windows is an exe file. Now when it's done linking it, then it now zips it to either be an a.out file or an a.exe file that can be executable. By mean executable, that can now be run on any machine. Now that is basically how your C file is being compiled. It first starts from the preprocessor. After the preprocessor, it goes down to the compiler. After the compiler, it goes down to the assembler. After the assembler, it goes down to the linker. Now you can actually stop. Now when you actually compile your code without passing in the particular flags to stop it at this particular process, by default your compiler passes through all the phases, because it's only on the linker you get an exe, a binary executable file. It's only after it has passed through the linker. So from the preprocessor, compiler, and assembler, you don't have an executable file. It's only when it has passed through the linker, it is then you get the executable file. So if you are compiling your C file, and then there are some stuffs you need to do, or there are some requirements you need to get now that meets a particular condition, you can actually stop the compilation process at each of these stages, probably the preprocessor stage, probably on the compiler stage, or probably on the assembler phase. It is left for you as a programmer to actually fix, or to actually decide. Alright, so now let's proceed. Now we are going on the C file structure. Now this is our first encounter, or to greater part, or to many of us, this will be our first encounter in C language. Now the C language has its own, I call it a boilerplate now, or a template, but for me it has three things that you just have to follow. The very first one is your header files. By header files, I mean the libraries you'll be including, or the functions you'll be including, stuff like that. Now if you look at this example, now I said hash include stdio.h. now the stdio.h is actually a header file. More so, it actually was a library on its own. Now the hash include is actually a macro, which is going to be when I start compiling my C program, now if I pass it through the preprocessor, you get to realize that the output of the preprocessor, you won't see this hash include, because it's the job of the preprocessor to actually remove my macros. So now in this example, hash include here is hash include stdio is actually what? My header files. Now I'm saying that, okay, include the standard input and have output header library to this my code. Why would they want, why am I saying it should include? Because I'm going to be using a function which is defined in that library. That's the reason why you have to include it. If you don't include it, you get an error of undefined reference to the name of the function you are using. Now if I don't do this particular, which is hash include stdio.h, and I'm using the printf function, if you look closely in the body of my code, I'm using the printf function, and this printf function is actually defined in the stdio.h. Now if I don't include the stdio.h file, header file, to my C file, in the process of compiling this my code, that means after it has passed through the preprocessor, it gets to what the compilation stage. It's on the compilation stage, it's now going to stop there. It won't proceed to the assembler, because why? There is an error there. You get an error there because printf is actually a function which is needed by your compiler to actually get its function definition. Now while compiling, it couldn't see the function definition for printf, so it's going to sprung in the error undefined reference, meaning you've not defined the function printf in any of the file. Now that I'm including the stdio.h file, the next structure you need to know is what is the documentation. Now for this is, for us here, it's everything in between our comments. Now the forward slash asterisk it's a way of you writing comments in multiple lines. For writing a single line comment, you basically use the double forward slash for single line comment, and forward slash asterisk forward slash for multi-line comments. Now this particular part, when I wrote my main demo program return 0 when successful, more or less your documentation, like the purpose why you're writing the program, what the program does, the name of the program, the version, and other stuff that you want to include in your C program. Now the last part here is what? Your function definition, like what you are actually going to do. Now you can see now the very first function I have here was the int main, and the void there is basically saying my main function is not accepting any argument. I can actually change this particular function to be void main void, meaning I'm not returning any value, and also not accepting any argument. Now why am I calling it function definition? To some persons they call it other ways, but for me I just like calling it function definition. This is why the main itself is a function. Now by default, program compilation starts, or program execution starts from your main. So main is actually the first function in which that is being executed before other functions, and on the main function you have blocks of instructions. Now when we get to functions in C, you see that there are two types, there are two parts of the function: the function declaration, which is sometimes called the function prototype, and the function definition. Now in the function definition, you are basically saying what that function will do. Now if you look closely, in all C file, the int main is basically going to contain what that your program is all about. So that's why I like calling it the header file, the documentation, and then my function definition. Because even if you are going to write a billion lines of code, it must start from your main. Although there are ways you can actually you can actually stop your program to start from main and start from another function instead of your main, but then we'll try and keep things quite simple here. Now let me quickly explain this simple code you have written in C. Now the very first one here was saying what I'm including the stdio.h library. Now I'm making some documentation or some comments, and I'm saying that okay, the main here is just a demo program and it's going to return 0 when successful. The next one is what saying int main void. Now I'm saying that I'm going to return an integer from the main function and I'm not accepting any argument. That's why I'm passing in void there. Now when the job control gets to the body of the main function, the first function it sees is the printf function, and then I'm printing out a string. Don't worry, we'll get to discuss about the data types in C, and also talk on strings and characters. But then I'm calling the printf function, and then I'm saying that I'm going to print a particular string called what? Sammy Kings. The \n there is basically saying after printing, I want you to also print in the new line character, so that I don't get to see the next prompt immediately after the last output file. So that just basically looks clean. Then the return there is more like an exit status. So I'm saying I'm returning 0. To some programmers, they prefer to write return success. Success actually is actually equal to 0, while exit failure actually equals to 1. So whichever, if you're going to be using the digits, you can just use 0 and 1. If you're going to be using the macro, which is exit status, which is the success or failure, whichever one you decide to use, you can actually use that. But then I really prefer using the digits. It at least saves me some keystrokes. Now this is what I get when I compile it. Now I'm going to be using GCC as my compiler here. Now I'm saying that GCC, I want you to compile the test file.c. Now the flag O is basically saying after you are done compiling it. Remember I said the default after the linker is done linking these functions. The default for a Linux machine is a.out. Now if I pass in the flag O to my GCC command, I'm basically telling GCC that after you're done linking, instead of you to save this exe file in a file called a.out, I want you to save it in a file called test. So once this particular line is executed, I will have an executable file called test. Now to run the file, I'm basically going to say ./test, which basically says that I want to run this particular file in this directory. Remember the dot signifies your current directory. So when I run that file, because it is only a printf statement I wrote there, I'm only getting a display which is what? Sammy Kings. Now you could see that the prompt moves to the next line. If I had removed this \n, you see my prompt immediately close to the X there, which it doesn't make it clean. That's why I added in the \n. So now let's proceed. Now we'll be talking on the simple input and output functions in C. Now, these are the basic functions. There are other functions you can actually basically use to get input from a user. Now we're talking on the get C, the get char, the get S, put C, put S, put char, scanf, and printf. Now the get C and the get char they basically do the same thing. Now the difference is the fact that what they do basically is actually what? To get inputs, not just inputs, to get character inputs. By character input I mean a single character from the standard input is basically going to read a single character. That means if you are passing in something like Sammy, which in this case is 5-letter words, and you are passing Sammy via your keyboard. Now the get C and the get char is only going to read the first letter. It's going to take into acknowledgement that other characters are still there, but then it's only going to read the first letter because its job is to read a single character. Now the difference between get C and the get char. Now the get C will display what is being read. That means if you are typing in Sammy, you are going to see what you are typing. But the get char doesn't do that, but it's there. More like when you are doing your git push and then you put in your password or you put in your token and then you don't see it being displayed. Yeah, stuff like that. The get char won't display what is being read to the user. It's basically just going to read it. Just going to read from the buffer. Just going to read it and then saves it to a particular variable or probably reads and then writes to another file. That's the difference between the get C and the get char. Now the get S, now remember the get C and the get char reads a single character, but the get S in this case reads what? A complete string. They read a complete string. Now if you are passing in a string now, which is Sammy in this our example. Now Sammy, what is a string and what is a character? Okay, a string is basically an array of characters. Therefore means that if you have more than one character, it becomes a string. But if you have a single character or a single alphabet, you just have a character. So if I want to read a complete string, I can use my get S to do that, or I can use in my scanf to actually read a complete string. Now how does these functions know when to stop? They basically know when to stop when you press in your return key, which it can be likened to your enter key. So immediately you press in enter, it fires the signal that yes, it fires the signal that you are done reading, and then it continues its process. Now the put S, put C, and the put char is responsible for displaying character or string to the standard output. Now the put S, just like the get S, displays a string to the standard output, just like the way your printf displays a string to the standard output. Now you can actually use format specifiers on the printf to actually display character or display strings, or even combination of both. the s gets a string from the standard input. You put s displays a string to the standard output. The putchar displays only a single character. The put c2 only displays a single character. While printf, we've seen it before, it displays what? Both single and basically displays strings. Now let's talk about what? Variables in C programming. Now these are the variables that we have in C programming. We have the character, the signed short int, the unsigned short int, the signed int, or which is called the int, the unsigned int, the float, the double, the long double, the long double. Now in our next teaching series, we'll basically be looking at characters, the integers, the floats, the double and the long double in details. But quickly, I would like to show you a practical demonstration of what we have learnt, so that you get to see it visually, not just seeing it in a seeing it in a much more verbal or presentation manner. You get to see it visually. Alright guys, thank you. Alright, now we'll be practicalizing what we learned in the lesson. Now I'm going to be writing the simple function, and then I'm also going to be showing you how to practically include standard libraries. I'm also going to show you how to implement some input and output functions. So just watch. Okay, now this hash included stdio io.h is missing. I want to include the standard input and output header file that contains the standard input and output functions that I'll be using in this particular test file that I'm going to be writing. Now as you can see, In the example, I added the backslash n. Now in this particular example, I want to add the backslash n, then I want to show you what's going to happen. You see that if I don't add this backslash n, it's just going to be printed and then followed by my prompt. So just watch.